In solar thermal and for domestic thermal systems, we have two main types of application. One is a thermal siphon, where you have a solar panel that collects the energy, and you have a hot water tank that stores that energy, and all of this circuit can be done without having any pump. Since the hot water rises, it will be stored in the tank above the collector, and then cold water will come to the collector to be heated. Or we can have a forced circulation with a pump, and this pump drives the fluid through the solar circuit from the panels into the storage tank. The thermal siphon is a system that works by gravity. It's simple, it has less components and a lower investment, it has a slightly lower output, and it's easier to install. A forced circulation system has a pump, it's a bit more complex, requires a higher investment, slightly higher output. It's typical in colder locations, like in Northern Europe and Northern America. And here we can see a graph showing the thermal siphon on one side and a forced circulation system with a pump on the other side, both having storage. This is a solar system with storage, and here we see there is a solar loop that circulates having a pump. It goes into a coil inside of a hot water tank, and through this coil the energy is transferred into the water that is inside the tank, and eventually, if the water is not hot enough, there is still a backup system that brings the temperature of the water to the desired conditions. A control system checks out the temperatures and regulates the flow using for this the pump that can operate in different velocities. Another way of having this backup is with instantaneous gas water heater that can rise the temperature to the desired level, starting from any given temperature that comes from the storage. Here we can see a typical solar installation with a thermal siphon placed on the roof, cold water from the grid, and then hot water from the tank into the household, eventually having also a backup system if needed. And a forced circulation system, and in this case you can see that the storage tank is placed inside the house, and there is a controller that defines the speed of the pump, and by defining the speed of the pump we can achieve a certain flow, and by this energy is transferred outside from the collector to the storage tank, and from there to the consumer point. This is how it looks like more in detail. The solar radiation hitting the solar thermal panel. Here we can see that the fluid is being heated and hot water is then supplied internally to the consumer. Here a more detailed information about the forced circulation system with the different valves in the circuit. We have the collector, we have safety valves because of the pressure inside of the system. We have a pump circulating the fluid. We have a purge valve in order to be able to eliminate air in the system. We have a shut-off valve and also a flow meter so that we know how much is the flow through the circuit. And of course, since this is a system that deals with pressures, we have an expansion chamber, normally a vessel, where the pressure can be in equilibrium.